Okay, so in this video we're going to be looking at object-oriented design concepts, or sometimes called object-oriented programming concepts. So I've covered a lot of these concepts before in a previous video, but I'm hoping this video will provide some clarification on these concepts. So when we think about object-oriented design, we're really thinking about being able to model some sort of complex or potentially complex, and maybe it's not so complex, system in terms of some objects. And these objects can really describe anything. These objects can also interact with one another. And one of the main things that we need to get an understanding of when we start talking about object-oriented design or object-oriented programming is this idea of what is an object and what is a class. In terms of classes, we say that a class is just simply a blueprint or a template. It's defining something in terms of data and operations. So let's look at some examples to clarify some of these ideas. Okay, so for our first example, we're going to model this idea of a television. And most everyone's familiar with the idea of a television. A television has a lot of data associated with it, or a lot of state information associated with it. So when we think about a television, we could say, oh, is this television on? Is this television off? What channel is it on? What's the volume level? So all of these things here that we just said, the on, the off, the channel, the volume level, it would all be the data or the state information associated with the television. Now, in terms of operations, we can imagine being able to turn off the television or turn on the television, to change the channel, to change the volume. So now we're actually being able to manipulate the state information associated with the television. So this is really what we need to be thinking about when we think about televisions, or being able to model a television in terms of a class, is its data and its operations. Let's look at another example. Okay, so a bank account. When we think about a bank account, we once again would want to think about the data and operations. So for the data information associated with the bank account, we think about the name associated with that bank account. Maybe they have an ID, the amount that they have in savings, the amount that they have in checking. So all of this stuff is things that we can know about a bank account. So when we think about data, or attributes, or properties, these are things that we can know about some particular thing. Now in terms of the operations, we can think about having an operation to change the name on the account, maybe to do a deposit operation, and that deposit could occur on savings, it could occur on the checking account. And then we could also think about doing the opposite of that, being able to withdraw money. So certainly we're not being exhaustive in terms of all the various operations or even all the data associated with the bank account. But hopefully this gets you into the idea of thinking about, what do we need to describe in terms of data and operations. Let's look at one more example, and that's the idea of superheroes. So when we think about a superhero, we could also model a superhero in terms of its data and its operations. So in terms of its data, we could think of the name of the superhero. So Batman, Superman, Spider-Man, Hulk, Green Lantern, Iron Man, doesn't matter, whatever the name may be. Alternate identity, so Bruce Wayne, Clark Kent, Bruce Banner, whatever, the alternate identity or secret identity may be. In some cases, their identities aren't so secret. Superpowers that they may have. So can they fly? Do they have human strength? What is their height? What is their weight? Maybe that's something more mundane, like are they hungry or not? So we can have superheroes that get hungry. So all this stuff is things that we could know about a particular superhero, or the attributes associated with a superhero. Now in terms of the operations, there could be a lot of things, right? A superhero could fly, maybe it could lift some particular object, maybe it could eat, maybe it could sleep. Again, we've described some more mundane things associated with superheroes. But again, these are operations that a superhero could do. So in the case of eating, maybe this relieves the superhero from being hungry anymore. If hungry, it was like a state information, some sort of Boolean value. So hopefully you have an idea now in terms of what are we talking about when we would describe a class. And when we're talking about a class, it's just, again, a blueprint or a template to describe something in terms of its data and its operations. So now let's look at this idea of objects. So we know what a class is. Class, again, is that blueprint, that template that describes something in terms of its data and its operation. Well, an object is just simply an instance of a class. So we're talking about a specific superhero or a specific bank account. So now that we have a definition for what an object is, it being an instance of a class, let's go back to our superhero example and take a look at specific instances of the superhero class. So here we have two instances of the superhero class, one of them describing the Hulk and the other one describing Rogue. So if we look at Hulk, in terms of its data, we would have its name being Hulk, alternate identity being Bruce Banner, superpowers, it's got unlimited strength, its weight, 1,200 pounds, height, 7'8", hungry, maybe he's hungry for whatever reason. So all these things would be associated with a specific instance of the superhero class. And while I don't have any operations being specified here, certainly we could think about the operations of eating, the operations of jumping or leaping or lifting. So all of those things can be performed by this specific instance of the superhero class. So if we were to look at Rogue, we can see that she still has a name, an alternate identity, superpowers, weight, height, all the information that we had discussed before in terms of each superhero, but it's specific to her. It's specific to this instance of the superhero class. So hopefully this sort of drives home the point of whenever we're talking about an object, it's an instance of a class. Again, when we think about a class, it's just a blueprint or a template. You can almost think of it as a recipe. So a recipe allows you to bake hundreds of pies or make a sandwich or whatever it is that you may be doing. A blueprint would allow you to go in and build a house or multiple houses from that particular blueprint. It's the same idea here. We can go in and instantiate or create multiple superheroes or multiple bank accounts or multiple televisions just from the blueprint or the template or the class that we have. Okay, so now that we have a good grasp, hopefully, of what an object is and what a class is, I want to look at some specific terms that you'll often see when you're dealing with object-oriented programming in terms of defining a class. The first term that we're going to look at is this idea of instance variables. So we've seen instance variables. We just called them data or attributes or state information that is specific to an instance. So if we go back to our superhero example, whenever we were listing out the name, the alternate identity, superpower, height, weight, hungry, all those things there were instance variables. And we also saw this idea of instance methods. So these are operations or behaviors that are specific to an instance of a class or an object. So again, if we go back to our superhero example, fly, lift, eat, sleep, all these things are operations that would be specific to a particular superhero. So we're not saying that other superheroes cannot fly or lift or eat stuff, but we would say in writing a program that we would want Superman to fly, or we would want the Hulk to lift something, or Batman to lift something, or Iron Man to sleep, or whatever it may be. So we would have to be referring to a specific instance of the class to perform some specific operation. So class variables, we didn't see any specific examples dealing with class variables, but these are just data and attributes or state information that's not specific to any particular instance. One class variable that's quite common whenever we're talking about the creation of classes is a variable that keeps track of how many objects we have of a certain type. So how many superheroes do we have? How many bank accounts do we have? How many televisions do we have? So this is information or this is data that's not specific to any particular instance of that class. Class methods, same concept is class variables, except now we're applying it to operations. So these are operations that aren't specific to any particular instance. So there may be an operation in a bank account to be able to change the interest rate. So maybe all the bank accounts associated with a particular bank have a particular interest rate for a 6-month CD. So we could perform some operation to maybe update that, either increase the interest rate or decrease the interest rate. That would be occurring through a class method because it would apply to everyone that was at that particular bank. And then finally, the idea of a constructor or constructors. So these are just special methods that instantiate or create and initialize an object. Whenever we go and do a specific example using all these ideas, we'll see this idea of a constructor. Okay, so that pretty much wraps up this video, and hopefully you've gained better insight into these concepts of object-oriented programming and specifically the idea of objects and classes. And in my next video, I'm going to be going in, writing a particular class definition. We'll be making use of instance variables, instance methods, class variables, class methods, and also constructors. And we'll use our superhero example for that one.